Welcome students. In this video, let us look at how to find the maximum and minimum values of a rational quadratic. That is, the numerator contains a quadratic and the denominator contains a quadratic. So what are the maximum and minimum values of expressions like this? So how do we do these type of questions? So there is a standard process to solve these type of questions. First is, let us assume y is equal to x square minus 3x plus 4 by x square plus 3x plus 4. So let us assume that the given expression is y. Now I want the maximum and minimum values of this expression. That means I want the maximum and minimum values of y. So let us see for what values of x, y is defined. For what values of x, y is defined, or for what values of y, you can find a fixed value of x. Now, what I do is, I'll try to construct a quadratic in x. So let us do the cross multiplication. You get yx square plus 3xy plus 4y is equal to x square minus 3x plus 4, and this implies x square times y minus 1. So let us try to convert this into a quadratic in x. X square times y minus 1 plus x times 3y plus 3, right? If minus 3x comes onto this side, it becomes plus 3x. So x times 3y plus 3 plus 4y minus 4 is equal to 0. So you get a quadratic in x. This implies what should be the value of x in terms of y. So if this is a quadratic in x, you have y minus 1, 3y plus 3 and 4y minus 4 as the coefficients. So x is equal to minus b minus of 3y plus 3 plus minus root of b square 3y plus 3 whole square minus 4 times 4y minus 4 times y minus 1 divided by 2 times y minus 1. So x is equal to minus b plus or minus root of b square minus 4ac by 2a. Now, for a real x to be defined for some value of y, for example, if you put y is equal to 3, so my question is, will y be equal to 3 for certain values of x? So correspond to y is equal to 3, if you have to get some value of correspond to y is equal to 3, if you wish to get some value of x, the condition is that the value inside the square root has to be positive. So for a real x to be defined corresponding to a y, then this discriminant has to be positive. So this implies for real x for certain value of y, for real x to be defined for certain values of y, y should maintain this discriminant to be positive. That means 9y square plus 9 plus 18y minus, this is 4 into 4, 16 times y minus 1 whole square. That is 16 times y square minus 2y plus 1 has to be greater than or equal to 0. This implies 9y square minus 16y square minus 7y square, 18y plus 32y, 16 2s are 32, 18y plus 32y is 50y, 9 minus 16 is minus 7 is greater than or equal to 0. This implies 7y square minus 50y plus 7 is less than or equal to 0. This implies 7y square. So 50 can be written as minus 49 minus 1. So minus 49y minus y plus 7 is less than or equal to 0. This implies 7y times y minus 7 minus 1 times y minus 7 is less than or equal to 0. This implies 7y minus 1 times y minus 7 is less than or equal to 0. A quadratic expression less than or equal to 0 implies y lies between the roots. So y has to belong to 1 by 7 to 7. That means if a real x has to be defined corresponding to a given value of y, then y has to be in between 1 by 7 and 7. Only for these values of y, an x will be defined. Now, if you try to relate this information with the question, you are asked to find the maximum and minimum values of the expression. That is, the maximum and minimum values of y. The maximum and minimum values of y for which a real x is defined is nothing but 1 by 7 to 7. So the maximum value is 7, the minimum value is 1 by 7. So this is a standard algorithm to find the maximum and minimum values of a quadratic rational. First you assume that the rational as y, you do the cross multiplication, create an equation, create a quadratic equation in x, write x as minus b plus minus root of b square minus 4ac by 2a, and the discriminant of this equation has to be greater than or equal to 0 for an x to be defined correspond to a y. So once you solve the inequality, you get the limits of y. From the limits you get the maximum and minimum values of the expression.